This is the Building Automation Monthly Podcast with Phil Zito, episode 94. Hey folks, Phil Zito here, and welcome to episode 94 of the Building Automation Monthly Podcast. And in this episode, I'm going to be discussing 10 ways to increase your building's energy efficiency. So in the previous two episodes, we talked about preventative maintenance with building automation systems. Now, let's assume that you've gotten your building automation system in check, everything's working well, and now you want to take your building automation system to the next level. Maybe you are a technician, or you are an owner, or you're an engineer, and you're looking for ways to go and enhance the efficiency of a building automation system. Well, in this episode, we're going to be discussing 10 ways to do that. So without further ado, let's dive into way number one. So way number one is to ensure your schedules are accurate. Now, we talked about this a little bit in the previous episodes, but this is a little more detailed. So we're assuming that you have schedules set up and that your schedules are set up by piece of equipment. But are your schedules accurate? And more importantly, are they optimized? So your schedule should, in an ideal world, turn on when people are in the building and turn off when people leave the building. However, there are a couple tips you can take that will allow you to kind of optimize how you schedule your equipment. One tip is to cut the schedule 30 minutes before people actually leave the building. Now, here's what I mean by cut the schedule. I don't mean that you turn off the equipment, but maybe you move the equipment into a lower mode. Maybe you're doing less of conditioning, you're just returning air, and you're going and mixing that return air with outdoor air. That's a potential way. There's a couple things you need to be aware of as you go and turn off or lower the set points of equipment. And those things are that you really need to make sure you're maintaining your CO2 levels within the space. You also need to maintain some form of flow. If you're at the right humidity level, you can actually have flow coming through your units and have that flow at a higher temperature, and people still feel cool. And you'd be surprised by cutting 30 to 20 minutes out of a schedule. If you stretch that across a full year, you can actually start to see some efficiencies. And so you could start maybe with 10, 15 minutes where you cut the schedule 10, 15 minutes before people normally leave the building. Let's say people leave at 5, you cut it at 4:50, 4:45. Now that may not seem like a lot, but you do that over a year, and that's almost an hour each week. That's almost 52 hours of runtime just with 10 minutes. Now, you can continue to do that until you hit a point at which the environment, the conditions of the environment deteriorate. Usually that's about at the 30-minute mark. Most spaces are 4 to 6 air changes, meaning that the volume of air will change within the space every 15 to 10 minutes. And what that means for you is that you're going to go and have, maybe 2 air changes that you can do before the air gets hot enough that folks are like, it's getting uncomfortable. But by that time, most of the folks will have left the building or be packing up to leave the building, and so they're more tolerant of that. If you're able to dial things down to that 30-minute window where you're cutting 30 minutes out of your schedule, then that can become, what is that? That's 2.5 hours a week, and let's times that by 10. That's 25 times 5. That's roughly almost 130 hours a year that you're saving on your runtime of your equipment. That's a lot of hours. And considering that when you dial back set points or you turn something to unoccupied or maybe a lower flow, you're actually going to be needing less heating or less cooling. You're going to have downstream and upstream effects. Downstream to your boxes and upstream to your chillers and your boilers. Now, way number 2 is to set the proper changeover temperatures. You see, quite often you'll have a summer-winter changeover where at 60 degrees you'll enable the chilled water plant, and at around 55, 50 degrees, you'll enable the hot water plant. But that's not necessarily optimal. You have to take into account the humidity level of the air outside. You have to take into account the exposure of the building. Is it a primarily southern facing building where it's going to take advantage of solar gain? You have to factor all of these things in when you're going and creating your changeover temperatures. If you simply stick with the tried and true 60 or 65 degrees for your cooling and 50 or 55 degrees for your heating, you may be going and conditioning a building and kicking on heating or cooling when you don't need to. You need to really look at what kind of insulation you have, which way is the building face, what kind of operations are going on, what is the demographic in the building. All of that should affect how you go and enable or disable heating and cooling. So that would be way number 2. Now, way number 3, we talked about this in previous episodes, but you really want to avoid using overrides as much as possible. Whenever possible, use timed overrides. Do not use actual static overrides. And what is an override? That is when a point is being commanded to a certain value. Maybe it's a valve, maybe it's an on-off for a fan, and you override that value. You want to avoid any overrides as much as possible. Because assuming that your equipment is actually controlling to the sequence and assuming that the sequence is actually any good, I'm making both those assumptions, then you shouldn't be overriding, because overriding is going to go and violate that sequence and quite often will have cascading effects to other systems. So you really want to be aware of that. Now, way number 4, and this is usually where a lot of folks will start, is looking at simultaneous heating and cooling. So what is simultaneous heating and cooling? You see it more in air handlers and you'll see it more in fan coil units, but this is where you're cooling the air only to be heating the air back up. Quite often in air handlers, this will happen due to a poorly controlled mixed air temperature. So what will happen is you'll be economizing air, and you won't be looking at controlling that mixed air temperature. And because of that, you'll actually end up subcooling the air, which then means you're going to have to heat the air up. An even worse example of this will be when you have no economizer control strategy and you just keep the economizer set at a certain percentage. So you're bringing in hot outdoor air and you're kind of cooling that outdoor air, and then you're having to heat that outdoor air back up. Now, the really nasty version of this, and you see this more on fan coils, is where the heating and cooling process loops, they get out of whack. Maybe they're misprogrammed, maybe they're not properly tuned, but for whatever reason, you have heating on and cooling on at the same time, and they're fighting each other. Now, how do you check for these things? Well, you need to go and have trends, first off, and you have to have trends at a decent interval. Typically, the 15-minute interval won't cut it for this, especially if you have oscillating valve actuators, meaning they're opening and shutting rapidly. In this case, you may want to go to change of value trends, where if it changes by more than 5%, you're going and logging that trend value. In this case, you'll be much more likely to see the heating and cooling happening at the same time. Once you find this, then you have to go resolve it. If you are capable of programming the controllers, which if you're a manufacturer or tech, you should be able to do that, you'd most likely want to go put some sort of state module in, meaning that when it's in heating state, cooling is not going to be able to be enabled, and vice versa. When it's in cooling state, the heating is not going to be enabled. That is the quickest way to fix simultaneous heating and cooling. It's not necessarily the best, but it is one of the quicker ways. The other way is, tuning loops properly, putting proper limits, not using a single PI loop for both heating and cooling. I've seen a lot of folks who will do that. They'll get a startup value on the PI loop of 50, so it automatically is at 50, and then from 50 to 100, that's 0 to 100 cooling, and from 50 to 0, that's 0 to 100 heating. And so they're using the same loop for both heating and cooling, which is bad because your heating and cooling should have different reaction times. You're most likely going to have a much larger cooling coil than heating coil, depending on where you're at. Thus, you're going to get a better response when you're going and cooling air. Versus the heating, you're going to get less of a response. So you need to be aware of that as well. Way number 5 is to make sure your dampers are not leaking. I mean, this seems fairly obvious, but you'd be surprised how many units I've seen in the past where the dampers are either not being controlled or manually set to a certain value. The actuator is actually off the shaft and or the linkage is broken. So these are all things that you want to be aware of. Outdoor air, depending on the size of the unit, can have a massive effect on the heat that you're introducing, especially if it's a humid area. Because we have to remember that what you're doing in most cases is that, one, you're trying to remove moisture from the air because moisture is going to contain more heat than air. Why is that? Because water can contain more BTUs than air, right? That's kind of basic heat transfer 101. Well, if moisture contains more heat, more BTUs than air does, than dry air, then naturally, if we have very humid outside air, we want to limit the amount that's coming in to the bare minimum to control to CO2. That's the air people put off when they breathe, carbon dioxide, and it's what makes people sleepy. And there's certain requirements based on ASHRAE 62 that you're supposed to meet for your spaces. So we really want to take our dampers and we want to make sure that our shafts are fully closed, and then sometimes we can even preload our damper actuators. Although some folks will say don't preload, some folks will say preload, but that's a strategy. You also want to make sure the seals on the damper blades themselves are good and that you're not going and having damper blades that even at 0% will never hold a seal. Now, I talked about software overrides a little bit earlier in way number 3. Now, way number 6 is something that is very sneaky, and I see this happen quite often when I'm asked to go look at customer sites to give them an assessment as to how they can drive energy savings and give them ideas. And they'll be so proud that they have no software overrides and that they're maintaining things. But then you get to the unit and you see the little Allen wrench key in the actuator and you realize that actuator's overridden, or the fan's overridden at the VFD, or a variety of things. I've even seen safeties jumped, which that's horrible, but it's just the reality. Folks are trying to fix stuff out in the field. They jump a safety to get a unit on because the low temp sensor keeps tripping. So they jump the safety for whatever reason and they manually crank the preheat valve to 100%. And then next thing you know, you've got this AHU that the cooling valve's always 100%, yet they're always at 62, 70 degrees, and they can't figure out why their discharge isn't controlling. Well, it's because the damper or the preheat valve, the actuator, has been overridden physically, and so that valve is physically 100% open. And those are really hard to catch unless you physically go there, because at first glance, you may go and miss it. You may look at a unit one day and the preheat valve is at 100% because the control system's commanding it there. But, it's at 100% really because it's manually put there. And so then when the control system's not commanding it, it's still preheating. And if you got skimpy and were cheap and decided, hey, I'm not going to put a preheat temp, I'm just going to control off discharge air, which some folks do, then you would not see that. So you definitely want at least once a year to do a physical check. Now, way number 7 is a controversial way. A lot of folks disagree with this. They say the cost is not worth it. I'm not going to get into whether the cost is worth it or not. I'll just let you make your own decision. But way number 7 is to make sure you have filter switches. I'm a firm believer of not filter DP sensors, but at least filter switches, where you're using something like an AFS 465, I believe it is. That's the airflow pressure sensor with automatic reset. And basically you set that to whatever your pressure drop is based on your filter type. And when it goes below that, when your pressure drop is getting to the point where it means you've got a dirty filter, then you're able to see that and you're able to go and fix those filters. Because I've seen filters sucked into fans, I've seen filters sucked into coils, and just in general, if your airflow can't get through, the motor's going to work harder. There's going to be less of an exchange as the air moves through the coils, so you're not going to get as good of heating or cooling. You're going to have to overwork those systems. In my opinion, in large air handlers and large rooftop units, investing in a filter switch is a no-brainer, because filters, whether you like it or not, have a dramatic effect on system performance. Now, way number 8 is to ensure your sensors are accurate. Now, this is not just calibrating your sensors, where we discussed that in the previous episode. So that's a given, right? That's a maintenance task you should be doing. But make sure that your sensors are actually accurate, meaning they're installed accurately. They're in the accurate place. So if hot air rises, would we want to put our mixed air temp sensor at the top, or would we want to put it at the bottom or the middle of the unit? These are kind of things. Or your low temp sensors, do you want the capillary running up, or do you want the capillary running down? These are all sensor installation things that you should be checking, and you should be checking these ideally when the building's built. The installer should be doing these right, and you should be validating that through either a commissioning agent or yourself. But at the same time, if you're inheriting an existing building, this is something very important. For example, I've seen discharge air temp sensors that are before the coil. Well, it doesn't do a whole lot of good to have reheat to control discharge air if the discharge air sensor is before the coil. Or you have pressure sensors that are supposed to be doing high static pressure, but they are sensing the atmosphere instead of actually the unit. And now you've got a pressure sensor that will never accurately work. Or where are you putting your 2/3 sensor? Is it actually 2/3 down the longest duct, or is it actually at a point where you're getting a good distribution of unit types? Meaning you've got VAV units and you're looking at, I've got some reheats, I've got some cooling onlys, I've got some fan power boxes. I want to get a good distribution. Or do you simply want to do the 2/3? It just depends on your control strategies, but these are all things you should be thinking about, because ensuring that the sensors are in the accurate spots and they are accurately installed is obviously going to have a massive effect on the unit's performance. If the sensor's not in the right spot, for example, it's not after the coil, how can the coil actually run a process loop that controls to the sensor? You would think that this stuff wouldn't occur, but if you've been in the field for any amount of time, you know as well as I do that this is actually fairly common, especially with safeties. Safeties are very often either miswired or the wrong circuit is used. Either they're using a normally closed circuit for status instead of a normally open circuit for status, and a variety of different things like that. Now, way number 9 is to reset your fill-in-the-blank set point. The most common ones are to have chilled water and hot water resets, and the reason these are most beneficial is rather than just waiting for the unit to, let's say you got a chiller and you say it's 42 degree chilled water supply, and your idea is that I'm going to produce 42 degree chilled water because I got a primary secondary loop, and the secondary loop is going to mix that water out as needed. So if I control that secondary loop, then I shouldn't have to worry about my set point. But the thing is that your chillers are still running to produce 42 degree water when they may not need to. That's why you can look at valve position, or you can look at discharge air of your units, of your air handling units, and then reset that water temperature set point. That's going to keep you from producing or removing those BTUs in the first place. In the case of chillers, you're removing BTUs. In the case of hot water systems, you're producing BTUs. You're basically transferring them in the form of combustion. And what you need to do here is, by resetting that, by getting as close to the initial process as possible, you're keeping those BTUs from being produced and introduced into the system. Now, what that allows you to do is save energy and also not work your equipment as hard. So I really, really recommend that you go and you do resets on your set points as much as possible. And finally, way number 10 is to consider enthalpy when using your economizer. Now, for some of you, you may be wondering what enthalpy is. Now, quite simply, enthalpy is just simply the amount of heat or energy in the air. Now, it's measured as BTUs per pound of air, if I'm remembering correctly. And it's pretty close to the wet bulb temperature, which basically factors in humidity. Now, if we remember that essentially moisture, right, water, is our enemy when we're working with outdoor air, because if I have 80 degrees at 30% relative humidity, that has significantly less energy that needs to be removed, less BTUs, because remember, BTUs transfer from hot to cold. So when I'm cooling that air, I'm going to be taking those BTUs out of that air and I'm going to be transferring them into the chilled water return. And that BTU is then either through an air-cooled chiller or through a condenser, through a cooling tower, is then exhausted back to the atmosphere. Well, by factoring in enthalpy rather than just looking at purely outdoor air, and this is more applicable in very humid states or kind of Midwestern states, and I'm talking about the United States here. I'm not an expert around the rest of the countries in the world, but you could probably make some assumptions. But essentially what you're doing is you're looking at the amount of moisture that is in the air, and then based on the amount of moisture that is in the air, you're making a decision of how to control your economizer. Now, this is a little more difficult, and enthalpy sensors can definitely be problematic, but it does go and provide you an opportunity, especially in situations where things are really humid, to go and control the amount of BTUs of energy you're introducing into your system. Because at the end of the day, right, we bring the outdoor air into the air handler, and that outdoor air then gets subcooled to dew point and then continues to get cooled, which then removes the moisture, and then either through heat gain through the ductwork or heat gain through some form of reheat, we then go and warm the air up, and that gives us a lower relative humidity and helps us reach that ASHRAE 62.1 thermal comfort zone. So by doing that, by controlling the enthalpy, we're able to introduce less heat energy, less BTUs into the system. Thus, we're able to get a better cooling effect. And we maybe even can go and bump up the temperature that we're controlling to for discharge air, because we'll have less humidity, so we need to subcool our air even less, because subcooling is the process of which we remove humidity from the air. So I know this was probably one of my more technical episodes, one of the ones where I kind of dived into some of the more thermodynamics and heat gain and heat transfer and a variety of topics you may not have heard me cover before, but nonetheless, this is something that is really important for folks, especially as we're starting to enter the new year and folks are looking at their budgets and they're trying to figure out what can they do. Their operational budgets are shrinking, or maybe you've got a customer who has come to you and said, hey, I need something new for this next year. I need you to come up with a new idea to help me out. Well, these are some ideas that you can go and look at inside your customer's site to potentially provide greater value, some potential retrofit opportunities or service opportunities. Because we all know things start to slow down around this time of the year, except for the failed boiler calls. And so this will give you some stuff that you could potentially work on with your customers to keep you gainfully employed. Now, with that being said, everything that I talked about will be accessible in the show notes at buildingautomationmonthly.com/94. Once again, that is buildingautomationmonthly.com/94. Now, depending on when you're listening to this, this may have already happened, but I want to let you all know that coming up in January, let me check my calendar here. I believe it is the 22nd of January, I will be teaching Building Automation Systems 101 at the ASHRAE Expo. So if you've been listening to my show for a while and you'd like to meet up, or you'd like to simply just come listen to BAS 101, I'd love to have you there. I think it's got room for a couple hundred seats. That would be absolutely awesome. And it'd be cool to just catch up with you at the show and shake your hand and get to meet the folks who are listening to me every week. That'd be awesome. Also, depending on when you're listening to this, I may have already went and implemented my new pricing model. I'm switching to a 3-tier model, which basically each course I will have a core module, which will be just a handful of modules from the course. That will be the first option, and that'll be priced around $99 to $199 depending on the course. The second tier will be the full course, but it won't include any quizzes. It won't include the coaching calls, and I have yet to decide on the price for that, but it'll be lower than the price of the full course is right now. And then the third tier will include the group coaching calls, will include all of the bonuses, all the lessons, the ability to download everything. And it'll also include quizzes and a certificate at the end. So once you've gone through it, you'll be able to answer the quizzes. And if you pass the quizzes, then you will go and be able to get a certificate for the course. So that will be the higher tier option, the third tier. So this will, at least I'm believing that this will allow more folks to be able to access the courses and at least get a first step. I realize a lot of folks are starting to try to get into building automation, and this will give you that ability. And the final thing I want to bring up is that my Building Automation Systems Fundamentals course is complete as of November, and that means that if you're looking to move into building automation systems, or you're new to building automation systems and you'd really like to learn about that, then this is a course you're definitely going to want to pick up. And by the time this episode goes live, the Building Automation Systems Fundamental course will have a sales page up, and I will link to that so that you can go and purchase that course. I really recommend. I've been getting a lot of great feedback from the beta customers on this about how it's really helped them understand building automation systems. It's going to take you through what you need to know to be able to start your career, and it's an invaluable first step on your building automation system journey. So that being said, like I said, everything is available at buildingautomationmonthly.com/94. I look forward to seeing your comments, and my only ask is that if this show has benefited you, then just go and share it with your coworkers and customers. Spread the word. I love the opportunity to share my thoughts and experiences with you. Thanks so much, and I'll talk to you all again next week. Take care.